Welcome back for the rest of Unit 1, Session two's notes. This is Unit 1, Session 2.2. We are starting with distance, the distance between 2 points. Here we have a few examples where you want to find the distance of each segment. Notice that we can write each of these segments with their proper coordinates. Now, when I say coordinates, we only have one number line. So therefore, we're only going to have one number in the coordinate. So let's call this number line x. And so therefore, we have g of -6 going to h of -2. Well, we can say that gh is equal to, and we want to find the length. So what's nice and easy about this example is that we can count. We can go 1, 2, 3, 4. And so we know that that's going to be 4 units apart, okay? And so from G to H, it's going to be 4. Now, if we look at E and F, we have E, which is at, again, -6, and we are going to F, which falls on 5. Essentially, what we're asking is how far, if they're both on the same side of the 0 sign, how far apart are they? And then if they're on opposite sides of the 0, well, how far is one from the 0 and how far is the other from the 0? So once we combine those, that's it. Well, we can see that E, all right, is going to be 6 units from 0. We can also see that F is going to be 5 units from 0. And they're both on the opposite sides, okay? So we have essentially 6 units here. And essentially we have 5 units here. Now remember, we need to have units. Since we don't have centimeters, inches, or anything like that, we just call them generic units. This tells us that EF is going to equal 6 plus 5. So we're going to end up with 11 units. Take a minute. Let's look at these numbers that we have real quick. Okay, from -6 to -2, we have 4 units. From -6 to 5, we have 11 units. How are we getting those numbers from those two numbers? Well, let's explore a little more. Let's go to 3. Let's go from C to D. So we're going to go from 3. And then D is going to be at 7. Well, this is fairly easy because they're both positive. So we can see that, okay, well, 3 to 7, that's going to be 4 units long. So how do we find that out? Well, one thing that we can say on a side note is that this is similar to 7 minus 3, which equals 4. Does that work for the other ones? Let's find out. Okay, we have 5 minus and negative 6, which equals 5 plus 6, which equals 11. That worked. And let's see, negative 2 minus a negative 6, which is essentially negative 2 plus 6, which gives us 4. Hey, that works as well. So it seems like if we continue this pattern, we can probably get the distance between 2 points being the largest number subtracting the smallest number. But we can also apply this to the opposite way. So it doesn't matter which difference we take. We can take the difference of the smallest and the largest, but we're going to end up with a negative, but we can change that to a positive. Okay? Let's figure this out. Okay, so if we have A, which is going to be 0, and we have B, which is going to be 6. Well, what if we do A minus B? Which is essentially going to give us 0 minus 6, which equals negative 6. Uh-oh. We have a negative measurement. We can never have a negative length. You're not going to say, I am going to target, which is negative 2 miles away. No, you would always change it into a positive. So what we can do is take the absolute value of all of these, and now we end up with 6. And so essentially we can say that AB is equal to 6 units. Now this is a one-dimensional way of finding distance. Okay, this is the distance formula for one dimension. When we have, say, x1 or x2 all on the same line, we can find the difference between those two and we can take the absolute value. So for example, we can say that, all right, AB is going to equal the absolute value of 2.2 minus 7.8, and this is going to give us the absolute value of negative 5.6. Taking the absolute value, we end up with 5.6. We can also do 7.8 minus 2.2. That's going to give us 5.6 as well. So we can say AB is going to equal 5.6 centimeters, or, and what I don't really like because these are a lot of numbers, but we can also say 56 millimeters. Let's take a look at CD. CD seems a little harder. Now remember, I'm not putting a line over because we're finding the measurement. We're applying a value to these. Remember what we learned in 2.1. All right, so now we're going to take 3 over 8 minus 3 and 3/4. We're going to take the absolute value of that now. We do need to change this because we don't want mixed fractions. And now, since we're subtracting fractions, we need to make sure that they have common denominators. Okay, and this is going to give us a negative 27 over 8, which is going to give us a positive 27 over 8 inches. Now, that is essentially not the way that we would like to look at it as. So what we would do is we would say, how many times does 8 go into 27? And it goes into it 3 times. So in this case, we would say CD equals 3 and 3/8 inches. And that's pretty close to 3 3/4, and that's because what we're subtracting a very small amount. So technically, if we look at this and let's draw a line here, and we're going to cut that line out, and we're going to move it over here. Essentially, this moment, now this isn't accurate, but essentially this moment here, well, let's move that one more time so that we're a little more accurate, okay? 3/4, move that here. So yeah, we can see that right here, that's where we're going to end. And we can see that we have 1, 2, 3, and that's 3/8. Now, what we're doing essentially here is applying the segment addition postulate, what we learned in the previous set of notes. Okay, that segment addition postulate is very important for you to know how to use. Okay? It might not be so apparent, but it can be very, very helpful. Okay. On your own, find the measure of GH. On your own, find the measure of GH. I will be looking for this in your notes to complete on your own. And we will do this in class together to show you how to make sure that you have the correct answer to this. Okay? All right, let's discuss the distance formula. The distance formula allows us to calculate the distance between two different points. So imagine we have point A, which is here, and we have point B, which is up here. We want to find the distance between these 2 points. Now, the hard way is, all right, well, we need to take a ruler, sit it down, graph it, look at it, analyze it, I don't know, try and figure that out. All right, scale it down, scale it up, whatever. But there is a distance formula that we can use. Now, as we see here, we have the change of x and we have the change in y. Remember, this little thing right here, this triangle next to the x is delta, which means to change or difference of. And so we need to find the difference of x. We need to find the difference of x and the difference of y. And we need to apply that to the Pythagorean theorem. So let's just try and do this. All right, I'm going to color code this. We're going to create a right triangle. And I'm going to label the blue. This is going to be our change in x. And our green is going to be our change in y. Now let's look at our x values. we have -3 to 5. And so the distance of x is going to be -3 minus 5, which is going to give us -8, which is going to give us 8. Okay, that is how long those units are. Now let's take a look at the y values. We start at -8 and we go up to 2. So we have -8 minus 2, which equals -10. But we're taking the absolute value, so the distance from x to 10 is going to be that. So let's say that the change of x is equal to 8, the change of y is equal to 10. We have a right triangle here, and so we can use the Pythagorean theorem. Now, if you don't know what the Pythagorean theorem is, that's okay. Pythagorean theorem has a squared plus b squared equals c squared, where a and b are essentially a can equal the change in x, and b can equal the change in y. They are the legs of the right triangle. C is the hypotenuse. It's the longest side. So C is actually our distance. C is equal to the distance. And so let's apply all this into the Pythagorean theorem. So therefore, if A is our change of x, we're going to say we have 8 squared plus 10 squared equaling, and let's say our difference or our distance squared, d squared. Now let's work this all out. We end up with 64 plus 100 equaling d squared. We end up with 164, which equals d squared. And so therefore, d is equal to the square root of 164. Now, what does that mean to us? Not much, but let's check it out. Okay. This is essentially 2 times radical of 41, which our distance is going to be about 12.8 units. So we can see that we can find the distance by applying this Pythagorean theorem. So we can actually use, now I've chunked it out for you, but we actually have a formula which looks like this. And just for clarification, don't write this. Don't write that, okay? It is just d equals the square root of the difference of x's squared plus the difference of y's squared. There's a few ways of writing this that can always make a little more sense. You can say something like d equals the square root of the change in x squared plus the change in y squared. All right, they mean the exact same thing, but this way you know that, okay, the change in x is equal to x1 minus x2. The change in y equals y1 minus y2. And so you can just find the difference from them and then square them. Okay? So if we were to find the distance between these 2 points without graphing it, it's pretty simple. All right, let's look at this. We're going to find our change in x, which is going to be 8 minus 4, which we get as 4. We get the change in y, which equals 9 minus negative 4, which we end up with 13. And so the distance in this case, the distance, we know the distance formula is going to be, what I like to say is the change in x squared plus x squared, all square rooted. And so we end up with 4 squared plus 13 squared and then square root. Uh, 16 plus 169 gives us 185. And so our distance is going to be about 13.6 units. I like to chunk it up. You can put it all into one big long thing and then enter it into your calculator and figure that out. That's perfectly fine as well. But what I like to do is I like to find the difference of x, the difference of y, take those two numbers and put them into the Pythagorean theorem. Okay, our next bit of information is midpoints. Now, midpoints are literally collinear to two endpoints of a segment and equidistant to those endpoints. One-dimensionally, all we need to do is find the average between the 2 points. So in this case, what we can say is, okay, if we want to find the midpoint, let's say M of G and H, we can say, all right, well, G is essentially 15 over 8. H is 51 over 8. And so if we add these two together, 15 over 8 plus 5.1 over 8, and then we divide it by 2. We get 66 over 8 divided by 2, which equals 33 over 8. And so therefore, our midpoint is going to be 4 and 1/8 of an inch. So let's find that. Okay. And essentially what we're saying here is that this side, this segment, and this segment are congruent. So therefore we can say that GM is congruent to MH, a congruency statement. Because that midpoint cuts this segment in half. And when it's cut in half, it has two equal lengths, which means they are the same size and they are the same object. Okay? They are the same measure. Two-dimensionally, if we are looking at here, we are really just doing the same exact thing we did one-dimensionally, but instead we are finding the average of both coordinates. So let's find the average between these 2 points. Okay, so we end up with -3 plus 5 all over 2. I'm going to say that this is going to be our point M. Our y's are going to be negative 8. Remember, it has to correspond with this. If we're starting with negative 3 plus 5, we have that negative 3 corresponds with negative 8. And then we got plus 2 all over 2. So M is going to be a 2 over 2. Negative 8 plus 2 is going to give us a negative 6 over 2. And so finally, our midpoint is going to be 1, negative 3. So let's find that on 1, negative 3. And again, what we can say is this side and this side are in fact congruent. We can check this by using the distance formula and making sure that the distance between the 2 points are the same. That can take a little bit of time, but if you have that time, it's always good to check your work to make sure that you did not make a mistake. So let's find the midpoint between A and B and verify it, okay? Verify it. This is going to take just a little bit of time, but let's call the midpoint C. So C is going to have the average of the x's, negative 4 plus 6, divided by 2, with the average of the y's, 3 plus negative 3 all over 2. So now C is going to give us 1 and 0. We can see that negative 4 plus 6 is going to give us positive 2 divided by 2 is going to be 1. 3 plus negative 3 cancels out, leaving us with 0, so that's going to be that. Now we can say, let's look at AC. The distance of AC is going to be essentially the x's. So we're going to go from A to C, so we have negative 4 minus 1 squared plus the y's, 3 minus 0 squared. So AC is going to equal 525 plus 9. And let's just leave it as that. Okay, we don't need to find the decimal or anything because verifying it just means that we want to find that if both AC and CB are going to be congruent, then we know that C is the midpoint. So let's find the distance between CB. Okay, difference of x from C, 1 minus 6 squared plus 0 minus negative 3. We can see that, all right, 1 minus 6 is going to give us a negative 5. Negative 5 squared is going to give us 25. 0 minus negative 3 is going to give us a positive 3 squared, which is going to be 9. So we end up with 34. Well, look at that. Essentially, AC is equal to CB. Which tells us that AC, segment AC is congruent to segment CB. And so therefore, C is a midpoint. Now, at the bottom of your page, I need to add a little information. Okay, because we need to describe what a angle bisector is. Actually, no. we'll do that in class. We'll have a little activity to discuss what a segment bisector is, not an angle, but a segment bisector. So, that is it for today. Till next time, signing out.